Hi all, in this video you will be now exploring the problems in SOP and POS with K-map for two variables. So now let us look into the problem solving of SOP and POS with K-map for two variables, and while minimizing we would see that there are two possible ways of asking the questions. Either the question would be asked in min terms or in the max term or in the Boolean expression form. But in later videos I will also let you know that how a truth table could be represented in terms of your K-map. So now let us take one example of two variable. Simplify the Boolean expression using K-map. So our main aim is to get the minimized expression of what we have been given. But to be noted is whether the given expression is an sum of product or product of sum. It is very well evident that what expression given to me is actually sum of product, that is, it is in the form of SOP expression. Now I have to design it into my K mapping. But before that, let me just give you a clue of how an expression could be converted into a binary representative or a binary form. So since I say it is an SOP, I have to be very mindful of noting that my original variable A will take the value 1 and my complementary will take the value 0. So keeping this in the mind, I may now represent this expression into binary as A to be represented as 1 and B complement as 0. Here it is 0 and 0 and here it is 0 and 1. Now further we can represent this binary form into our decimal form, right? So you can apply this concept to your 3 variable, to your 4 variable, to your 5 variable as per your convenience. And now let me teach you how a binary form could be converted into decimal form. You would have studied this in your lower classes, and now just recall that 2 power 0 is represented here and it is 2 power 1. Here it is 2 power 0, 2 power 1. Here it is 2 power 0, 2 power 1. So how do I write it into the decimal form? It is nothing but 1 into 2 power 1 plus 0 into 2 power 0. Here it is 0 into 2 power 1 and here it is 0 into 2 power 0. And the last one is it is 0 into 2 power 1 plus 1 into 2 power 0. So finally, when you simplify this, you would see that the decimal form of the first term is actually nothing but 0 plus 2. So it is 2 here, and here it is nothing but 0, and here it is nothing but 1. So this is actually nothing but my decimal form. So now let us just look into that how I design my K map. My K map is being designed for two variable in this way. So when I say my variable is 2, that means the number of cells that are to be in my design of K map is nothing but 4. So I should have 2 rows and 2 columns created. So I form a block where I have 2 rows and I have 2 columns, and I name this to be the variable A and this to be the variable B. Now B would take the value 0 and 1, A will take the value 0 and 1. Since the problem given to me is in SOP form, I am very mindful of representing my A, the original variable, as 1 and A complement to be 0. So I can name this expressions, these zeros and ones, as per the condition by A complement and A. Here it would be B complement and B. So now let us fill up this by representing it by the designation of the cell. So what is the designation of the cell out here? This has been designated as 0. This has been designated as 1. This cell is been designated as 2. This cell is been designated as 3. So now I will look into either my decimal form and fill up my K map by 1, because if it is an SOP, that is if it is in the min term, then I need to fill up my K map block with ones. So in place of 2 cell, I represent it by 1. In 0, I represent it by 1, and I represent this 1 cell as to be 1. So once I have filled up my K design with my ones, then next step is for grouping. So now I have to observe that in what way it could be grouped. So the grouping has to be done as large as possible. So here I have to check whether there is any possibility of quad grouping. I don't find any possibility. Is there any possibility of a pair grouping? Yes, I do observe that I can group this as one of my pair, and also I observe that I can group this as one of my another pair. So this is my group 2. Now I have to name these groups, or I have to represent this group 1 and group 2 in terms of expression. So how should we do it? So now when I look into my group G1, when I look into my group G1, I have to look into the corresponding row and the corresponding column. When I look into that corresponding row, it is a single variable, that is a complementary. So there is no comparison there out. But when I compare my column up, what do I see? That here there is a 0 and here there is a 1. I do have to check whether there is any common variable. So if it is in terms of variable, there up I see it is B and B complement, which is not the same. And if I look into my numbers, my binary number 0 and 1, which is different, so I do not find any expression further. So G1 is been named as a complementary. In the same way, let us name our G2 grouping. So if I look into my G2 grouping represents my 2 rows, and my 2 rows are named as 0 and 1, where I do observe that there is no constant binary number, or there is no constant expression. So I look into my column now. When I look into the column, I land up with a constant, that is a single number 0, and this 0 is been represented by B1. So now with this I have to come up with my conclusion of my output, that my expression could be now simplified or minimized in the form of A complementary plus B complementary. So if you just observe the given problem, you would realize that the given problem was this, and the simplified form is this. So here is a problem to make you understand that when it is an SOP for 2 variable, how your K-map design has to be understood. So now let us look into the second problem. Simplify the Boolean expression using K-map. Now if you just look into this expression that is being given to you, first you need to identify whether it is sum of product as SOP or product of sum POS. So here when I observe, I am able to identify this expression as an POS expression, or to be much more precise, this looks like my max term. Now I have to convert this into my binary to decimal for my simplicity. This is just to make the concept clear for you. Otherwise, you can very well with the variables design your K-map. So now, since it is POS, here you have to be very mindful of representing your A by 0 and your A complementary by 1. With this, now I understand this to be 0 and 0, this to be 1 and 0. So this is nothing but my binary representation or my binary form. How do I now understand this to be of my decimal form? Because I might be in use in filling up my K map in the K design. So now when it is 0 and 0, so you can just give a hint of 2 power 0 here, 2 power 1 here. So when I multiply the respective and add among it, I get my decimal form to be 0, and here it is 2 power 0, 2 power 1, where 0 into 2 power 0 plus 1 into 2 power 2 gives you 2. So now here my 0 and my 2 is the decimal form. So now let us go into designing our K-map. So how should we design our K-map? Since I identify this to be a two variable A and B, I am now bound to form a K-map with 4 cells as we saw in the previous problem. I name this as A, I name this as B, and I represent this to be 0, this to be 1, this to be 0, this to be 1. Now here the most important to be noted is how are you going to name these variables as? Since it is my max term, that is it is in the form of my POS, I am very thoughtful of representing my A by 0 and A complementary by 1. So now this becomes my A, this becomes my A complementary, this becomes my B, and this becomes my B complementary. My complementary could be designated in terms of dash or by this expression. Now I just name the cells. How do I name the cells? This is my 0, this is my 1, this is my 2, this is my 3. So now if you would like to fill up your K map with the help of the expression that you have got, you can very well do it. A plus B is nothing but this. Otherwise also, if you just look into the decimal form, you are filling up the 0th place. Now A complementary plus B, A complementary is here and B is here. So the place which you will be filling up as an output is nothing but this one. But let me tell you one thing, that when you had applied SOP, the K mapping was filled up with 1. But you have to be very mindful that when you fill up your POS, the filling has to be done with 0 only. So with this understanding, now I've changed this to 0. So what is my next task is to just look into the grouping. So here I observe that the grouping possible is only 1, and now I try naming it. So I name it by the technique of observing my rows. When I compare both, I don't see any variable to be the same or any of my binary form to be the same. So now I look into my column. My column is restricted to 1, so there is no comparison and I have to take it as it is. So it is nothing but B. So now how should I draw my conclusion? My conclusion would be now drawn as my F is equal to B. So now if you just look into the problem which you had got, you would now finally see that yes, you have minimized the whole Boolean expression using your K map. And here the example that was being given to you was POS. So when it is in the form of POS, the two things have to be very clear in your mind, that the filling of the K map has to be done only by zeros, and your A is represented by 0 and your complementary of A is represented by 1. I hope you would have understood the second example also. In this video, I think you would have got a clarity on how the K map is been designed for two variables for sum of product and product of sum problems. Thank you.